we're going to figure out Carmen's height, given that there's a 342 centimeter lamppost. That's this right here. And here's the tip of her shadow. This is her shadow right here. It's where she's blocking the light, which makes the shadow. And so let's call this point as it moves out, let's call the tip of her shadow T. So what they're telling us in terms of a rate is that, oh, I don't want T, do I? Because that's dt. So let's do a capital T. This is the tip of her shadow right here, that the rate that the tip of the shadow changes, the length, is twice the rate as she moves. So here's Carmen's distance from the lamppost. So let's call this x. And so this is going to be dx dt is the rate at which Carmen is walking. So this is Carmen moving that direction. As her x increases, as this x increases, the tip of the shadow changes. So if we were to draw this again, and we did this, let's say she's over here. Now, here's the tip of her shadow right here. So as she moves away from the light, the tip of her shadow is moving at a different rate. Okay, so here's the picture. You said you knew how to do this. The thing we need here are similar triangles. So if we would look at this big outside triangle in green, then let's call this S, that's the shadow. So basically the tip of the shadow is at a distance which is x plus s all the time, right? It's the distance she is from the pole plus the distance or the length of her shadow. So if we look at the big green triangle, we'll set up this ratio, which is that the tall side of the big triangle over the bottom, the horizontal side, is equal to, now we're going to do this purple triangle, the tall side of this purple triangle to the horizontal side of the purple triangle. So this is going to be h over s. Now, we could solve this for s if we wanted to. We really want to solve it for h. So if I would multiply both sides by s, I would have h, because what I'm looking for is Carmen's height. And that's a constant. So this is actually t. So I can do the change in her height with respect to time. If I do dh dt, it's a quotient. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom. Oh, this is implicit differentiation. I need ds dt here. Minus the top times the derivative of the bottom, which is dt all over the bottom squared. And that's supposed to equal dh dt. But the height isn't changing, so this is 0. So what I'm really solving is 342 times the distance from the pole to the tip of her shadow times ds dt minus 342 times s, the length of the shadow, dt. Now, we never figured out s, but s is t minus x. And so, if I want to know what ds dt is, it's just dt minus dx dt. And we know about dt and dx dt. So, and that equals 0. And so, this is 342 t times dt minus dx dt, because that's ds dt, and then minus 342s times ds or dt dt, which is 2 dx dt, right? We know that dt this. So I can divide both sides by 342 because this equals 0. And dt is 2 dx dt, so I can replace this with 2 dx dt. And now 2 dx dt minus 1 dx dt, that is a single dx dt, so I have t times dx dt minus s times 2 dx dt. Now, if I factor out a dx dt, I get t minus, whoops, I don't want equals here. I get t minus s minus 2s. This has a t, this has a 2, and that equals 0. Now we know that this is not 0, so t minus 2s must equal 0, or t equals 2s. So how does that get us to the height? Here it is. The height is 342s over t, and t is 2s, and the s's cancel, and this is divided by 2 is 171 centimeters. Now, did we need all that calculus is the question. Not sure, but I believe that's the right answer.